Hi students, it's Mrs. Weens, and today we're going to do a lesson on the primary trigonometric ratios. So you should have your note out with you, and you're going to be following along as I do the note. So sometimes you might want to pause the video and copy stuff down, and then restart so you can listen to me while I talk. You might want to add extra notes in the margins to make sure you understand what I'm asking. But you can watch this video more than once, as many times as you need to understand the material. So today our learning goals are to discover the meaning of sine, cos, and tan. So there's these buttons on your calculator. Hopefully you can see them. You might have been wondering this whole time, what are they for? What are they there for? Well, they are there to help you with trigonometry, which has to do with right triangles. So that's what we're going to get to. Then we're going to use them to solve for angles, so unknown angles in a triangle. And then we're going to use them to solve for unknown side lengths of a triangle. So trigonometry is derived from the Greek words for triangle and measure. So it's a branch of mathematics that studies triangles and the relationships between their sides and the angles between the sides. So Hipparchus, this is this handsome dude right here. He was a Greek astrologer, astronomer, geologist, and mathematician who lived a long time ago. So before Christ was even born. And he's considered the founder of trigonometry. So trigonometry has applications in astronomy, navigation, geography, satellites, music theory, acoustics, optics, electronics, biology, medical imaging, architecture, computer graphics, engineering. Honestly, basically everything has trigonometry in it. It's a very interesting branch of mathematics. In grade 10, we just stick with the basics, but in grade 11 and 12, we get a lot more advanced with our trigonometry. So this, your job in grade 10 is to just get a solid foundation so you're ready for that more advanced look at trigonometry. So we're first going to just start by just defining what sine, cos, and tan are on a triangle. So we're always going to be dealing with triangles. At the beginning here, we're going to be dealing with right triangles. Okay, so right triangles can be labeled in relation to an angle. So theta, this little symbol here is called theta. You're going to be drawing it a lot, so here you can kind of fill in the blank here with drawing theta. So the way I draw theta is usually like a circle, and then I just keep going, and there you go. Okay, some people draw it as a circle and then a line like that. Either way, but it looks a little fancier if you do it like that. Okay, so notice that theta in this triangle is our unknown side length. So a right triangle always has three sides. The first side is the hypotenuse. Okay, that's usually the easiest one to label, hypotenuse, because it's very clear. It's across from the right angle. It's the longest side. Okay, the next one I want you to label is opposite. So the opposite angle is opposite from, the opposite side is opposite from the angle that's labeled. So right now we want this angle. This is the angle that's being referred to. So this side over here is opposite. And if it helps you, you can even draw an arrow to show that it's opposite. Okay, and our third side length we call adjacent. Now, adjacent might not be a word that you use a lot, but it is just a normal English word that means next to something. So the adjacent angle is next to, the adjacent side is next to the angle. So the opposite is opposite from the angle. The adjacent side is next to the angle. If you don't remember what adjacent means, that's fine. Just leave it for the end and it's the last one left. Okay, so now in this right triangle, notice now that the angle we're referring to is up here instead of down there. So that doesn't change the hypotenuse. The hypotenuse is always the longest side, what we're used to calling the hypotenuse, but it does change where the opposite and the adjacent are. So now down here, this is the opposite side length because it's across, and this is the adjacent side length because it's next to. Okay, so this Hipparchus and other mathematicians have found that a relationship exists if you know an angle the ratio between the three sides stays the same. So no matter how big a triangle is, if it has a certain angle size, the ratio, for instance, of adjacent to hypotenuse is always the same. So you could have a really tiny little triangle, you know, really little guy, where the angle up here is 42 degrees, and maybe this is 2 to 1, and then you could have a big, huge triangle. And if this is still 42 degrees, so the same size as here, then if this is 6, okay, then this would be 3. So the ratio is still 2 to 1. So basically, these mathematicians found that because this is true, they could come up with names for those ratios. Okay, so they came up with the names sine, cosine, and tangent. So the sine ratio of any theta is just the ratio of the opposite to the hypotenuse. Okay, so in this case, it would be whatever this side length is divided by whatever this side length is. That ratio stays the same for any given theta, regardless of the size of the triangle. So for instance, if you take your calculator and you do sine 45 degrees. Okay, so sine 45 and press enter, you get 0.71. So that means that the ratio of the opposite to the hypotenuse is a 0.71 ratio for any triangle that has a 45-degree angle in it. That's what that means. If you do sine of 30 degrees, you get 0.5 or 1/2. So that means opposite to hypotenuse is a 1 to 2 ratio, okay, no matter how big the triangle is, if that angle is 30 degrees in that case, okay? Now, cosine just relates two different sides. So cosine relates adjacent to hypotenuse. So it's looking at if something is next to the angle versus the hypotenuse. It's looking at the ratio of those two sides. And then tangent is looking at opposite over adjacent. So the ratio, so that would be kind of like the picture I showed here. So opposite to adjacent of this known angle. It's looking at that. So basically, they've come up with a way to memorize these three ratios so that you remember them. So you might have heard other people saying SOHCAHTOA. So just means that sine is opposite over hypotenuse. Ka means that cos is adjacent over hypotenuse. And TOA just means that tan is opposite over adjacent. So the first letter in each of these stands for sine, cos, and tan, and then the second two letters are the ratio that is corresponding to each of those. SOHCAHTOA. So really, you probably just want to write this at the top of your quiz, the top of your exam, until you have it memorized, but it won't be too long because you'll be using it so much in your homework that you'll remember it shortly. Okay, so what can we actually do with SOHCAHTOA? Well, we're going to use it to find the length of unknown sides, and we're going to use it to find the size of unknown angles. So it is really quite a useful thing. But before we go do that, let's make sure we understand what's being asked. Okay, so here's a theta. It's an unknown angle, and they're asking us to name the primary trig ratios of this given angle. So what that means is that they want us to tell them what is the sine of theta, what is the cos of theta, and what is the tan of theta. Well, the sine of theta, if you remember SOHCAHTOA, so sine is O over H. So it helps us before we actually do this to make sure we label this triangle with the O, H, and the A. So since this is the reference angle, this here is the hypotenuse, the opposite is over here, and the adjacent is here. So having those labels just helps us make sure we're getting the right answer. So sine is just opposite over hypotenuse. So in this case, it's 3 over 5. So the ratio of the opposite side to the hypotenuse side is 3 to 5. For cosine, that's ka, so stands for A over H, so that's adjacent, 4, over hypotenuse, 5. Tan is TOA. So TOA stands for opposite over adjacent, so that's 3 over 4. So those are the primary trig ratios for theta. Okay, so we can use our calculators to calculate any of the 3 trig ratios of any angle. So if we did that, I did show this a second ago, but if you want to find the sine of 40 degrees, first of all, make sure your calculator is set to degrees. So if you have the same calculator as me, right there in that bottom corner, it should say DEG. It should not say RAD or GRD. So you want to make sure that it says DEG for degrees. If it doesn't, you need to press the DRG button, which is next to the second function, and switch it to degrees to make sure your calculator is in degrees. So how do we find the length of an unknown side? Well, you can pause the video and fill out these steps, and then I will kind of use them as I do example 1. I'm going to refer to all the steps at the same time. Okay, so we can use these trig ratios to solve for unknown side lengths as long as we know at least one angle and one side. We can still use Pythagorean theorem, but that means you need to know 2 side lengths to be able to find the third. Notice if I wanted to find this value of x, it's not enough for me to just know 5 to use Pythagorean theorem. I would also have to know how long the hypotenuse is, and in this case I don't. I just know that this is 60 degrees and that this is 5 centimeters. Now, because this is a 90-degree angle, I also technically know that this is 30 degrees since they all have to add up to 180, but I don't actually need that to solve this question. Okay, so they want me to find x is what they want me to do. So first things first, I'm going to label each side with O, A, and H based on the angle that I'm given. So notice that I'm given the angle here. So that means that this is my hypotenuse, this side is my opposite, and this side here is my adjacent. Okay, so I've done step 1. Step 2 says determine which ratio to use based on what is given and what is known. Well, I want O, okay, I want the opposite, and I have A. So I want O and I have A. So which ratio involves O and A? Well, it's tan. So if you're not sure, just have SOHCAHTOA written on the side to remind yourself. So which of these ratios has O and A? It's tan. So therefore I want to use tan since I have O and I want A. So that's step 2. Step 3 is to set up the trig ratio. So tan of 60 degrees equals O over A. So tan of 60 degrees equals x over 5, since my adjacent is 5. So that's step 3. Now I just need to solve for x. So that just means I need to get x by itself. So to get x alone, I multiply both sides by 5. So I get x equals 5 times tan of 60 degrees. And remember, tan of 60 degrees is just something I can use my calculator for. So I get out my calculator and I just write 5 times tan, and then it should start a bracket, 60, and the bracket, press enter, you should get 8.66. So that means that x is 8.6 centimeters. Sorry if that is written behind my head. It might be written behind my head, but 5 times tan 60 degrees should be 8.66 centimeters. And that's your answer for x. So now why does this work? Well, again, tan 60 is just the known ratio. So if an angle is 60 degrees, the ratio between the opposite and the adjacent is always the same. So your calculator just holds on to that information. And so you can use it, since you know that this is 5, the ratio for the ratio to be right for 60 degrees, then this x has to be 8.66. So back when like Mrs. Hernadeck or older teachers were in school, they actually had to use a book to find the ratios. It wasn't stored in their calculator. So luckily for us, we have calculators. We don't have to get a big book out that has all the tan, sine, and cos ratios written. Okay, so let's do the same steps here. So step 1, remember, is to label your hypotenuse, your opposite, and then your adjacent. Okay, step 2 is to determine what we need and what we know. So we know h, and we want O. So O and H, that comes from sine. So we're going to use sine because sine has O over H. Now we're going to set up our trig ratio. So sine of 22 degrees equals opposite over hypotenuse. So sine of 22 degrees equals x over 17. Okay, now the next step is to just get x all by itself. So x equals 17 times sine 22 degrees. Make sure you have that degree symbol there. So now you just get your calculator out, do it, and you get 6.37 centimeters. And that's how long x is. Okay. This one's a little different because you'll see why. So again, this is our hypotenuse, our opposite, and our adjacent. So we identify that we know A and we want H. So A and H, it's not sine, it's cos. Cos has ka, A and H. So therefore we're going to use cos. That's our second step. Step 3 is to set up our known ratio. So cos of 12 degrees is adjacent, so 6 over hypotenuse, which is x. So this is a little different because our unknown is in the denominator. So some students have trouble with that. But all you have to do is multiply both sides by x first. That brings x up top. So then we get x times cos 12 degrees equals 6. And now we want to get x by itself, so we divide both sides by cos 12 degrees. So you get x equals 6 divided by cos 12 degrees. Okay, and then you just put that in your calculator. So 6 divided by cos of 12 equals 6.13. And in this case, it would be meters. Okay? All right, and so then the final type of question is when you're not given a right triangle, you have to actually draw it yourself, so it just takes a little extra thinking. So it's a right triangle, so you can, draw it with a ruler, as I clearly am not, but that's okay. There we go. Make sure if it's a right triangle, you label your right angle side. Has one angle 28 degrees, so you label, it doesn't matter which one, because it didn't give you any information. With its opposite side measuring 9.2, so that's down here. Find the length of the hypotenuse, so here's the hypotenuse, and the adjacent side, so here's the adjacent side, and this is O. Okay, so you can do either one first. You can do H or O first, it doesn't matter. I'll just choose to do A first. Okay, so I want A, and I have O, so that's tan, O and A, TOA. So tan of 28 degrees equals opposite, 9.2, over adjacent, A. So I'll just call it A. All right, so then I bring the A up, and then I'll bring the tan 28 down. So really, once you see the math here, you can see that in the end, the x just goes up top and the cos 12 went down. So really, I can just trade those two guys spots. So A equals 9.2 divided by tan of 28 degrees. So your calculator is a wonderful thing, and it will tell you that that is 17.30 centimeters. Okay, so now I just need to find h. So I have two options. I can use trig. So I can use trig, SOHCAHTOA, or I can use Pythagorean theorem. Because I know that this is 9.2, I know that this is 17.30. So I'm going to use SOHCAHTOA just because, why not? So that's 17.3 squared plus 9.2 squared equals h squared. So that gives me that h squared is equal to 383.93. Then I take the square root of that, and I get h equals 19.6. Okay, now in this case, I don't have to put plus or minus 19.6 because we're talking about side length, and side length can't be negative. Okay, here is another example where I am, but it's just within a context. So this is a radio transmitter. It's supported by this guy wire. The wire is to form a 65-degree angle with the ground. So this is 65 degrees here. This has to be 90. And it needs to reach 30 meters up the transmitter. So this needs to be 30 meters high. The wire can be ordered in whole number lengths. How much wire should be ordered? So really it's asking us how long is this hypotenuse here in this right triangle. So notice that for the known angle, I'm given opposite and I want hypotenuse. So O and H, that's sine, SOHCAHTOA. So sine of 65 degrees is equal to opposite, so 30, over hypotenuse, so H. So H is equal to 30 divided by sine 65 degrees, which gives you 33.1. So that's how long this wire has to be. Well, because I need whole number lengths of meters and I need more than 33 meters, I need to order 34 meters of wire. So therefore, order 34 meters of wire. Okay, I would encourage you now to go to your practice on the last page of this note, just number 1, not number 2, and see if you can do a couple of these, okay? The answer for 1A should be 3.73. For 1B, which is down from A, it's 14.83. For 1C, it's 5.90. For 1D, it's 32.88. So you can try that. Okay, this last part is now, if we know the side lengths, how can we find the unknown angle? Okay, so I'm actually going to stop this video. Actually, no, I'm going to keep going. You guys can pause it, though, and take a break if you need to, but I'm going to keep recording on this one video. So you can use a scientific calculator to find the measure of an angle if you know its sine, cos, or tangent ratio. So you're going to use the inverse button. So if you look on your calculator, above the sine button, there's a little sine to the power of -1. That's called the inverse sine function, and it undoes a sine ratio. So, for instance, if you know that your sine ratio is this, you can undo this to say, what angle gives this special sine ratio? What angle is it that has this sine ratio? So try it now. You press second sine, and then on your screen it should say sine to the -1 bracket. And then you put in the 0.5736 and your bracket and press enter. So you should get 35.00 degrees, so basically 35 degrees. So this means that a sine of 35 degrees gives a ratio of 0.5736. So this allows us to undo ratios to find what angle give the ratio that we're given. So you can practice this by entering these into your calculator, okay? So to undo this, Now watch the notation. So to find what theta is, you would say cos to the -1 of 0.7767 equals. Okay, that's the notation. So you should get, in that case, sorry, just a second, 39 degrees. Okay, for example B here, the inverse tan of 5/4. So be careful. Notice how you're supposed to enter it. You do it that way. It has to be in brackets. Make sure you're getting 51 degrees. And for this last example, make sure, actually, sorry, you should have done for all of these theta equals because you're solving for the angle. You need to indicate to me that you're solving for the angle. There you go. So in this case, theta equals 49 degrees. So you can always round to the nearest angle. So what happens if you try to find the sine, the inverse sine of this? Okay, you should get an error. Okay, that's because all sine theta ratios are going to be less than or equal to 1, and all cos theta ratios will be less than or equal to 1 too. We can talk about this tomorrow, why that's true, or you can think about it. You should be able to figure out why that's true. Okay, if you really think about it and understand what these ratios mean, you should be able to figure that out. And you should also be able to figure out why tan, it's not true for tan, that it has to be less than or equal to 1. All right, so I've also set up the steps for you to find an unknown angle. So take a moment to pause the video and fill this out, and then I'll refer to it as I go through the examples. Okay, so the first step, again, is to label the sides. So here's the theta that we want to find. Now we want to find what this angle is. So this is the hypotenuse, this guy is the opposite, and this guy here is the adjacent. So that is step 1 complete. Now we want to determine which ratio is going to be used. So notice that we know O and H. So what do you think we want to use? Sine, because sine has O and H in it. So that's step 2. Step 3 is to set up the trig ratio. So the sine of theta is equal to 3.2 divided by 5.7. That's step 3. So now we just want to use our calculator to solve this for us. So we're going to write it theta equals, you can't just follow the equal sign down because now we're equaling something different. The inverse sine of 3.2 divided by 5.7. So you take out your calculator and you go second sine 3.2 divided by 5.7. You end the bracket and you should get 34.15 degrees, which we will round to 34 degrees. Okay, and we're done. So that means that this angle has to be 34 degrees for this ratio to hold true. Okay, let's try the next one. So in this case, we're given O and A. So therefore, TOA, we should use tan. So tan theta is equal to 3/4. So what angle gives a tan ratio of 3:4? So theta is equal to the inverse tan of 3/4. You put that in your calculator and you get 37 degrees. Okay, here's a word problem. So this is where Captain Jack is in communication with a submarine that is cruising at a depth of 400 meters. So that means that the depth, how far down it is, this side length here is 400 meters. This is where Jack is, by the way. This is where the submarine is. Jack's radar tells him that the sub is actually 500 meters from Jack, though, due north of his ship. At what angle is the submarine located with respect to Jack's ship? So they want us to come up with this. So this is the side view of the situation. So north is actually this way. So we're looking at it from the side. So his depth here, you could also have drawn the triangle here with the 400, Okay, the depth straight down of the submarine is 400, but the distance away is 500. So at what angle is it located? Here. So notice that we know adjacent and hypotenuse, so we want to use cos. So the cos of theta is equal to adjacent, 400, over hypotenuse, 500. Okay, so then our theta, we just take the inverse cos of 400 over 500, and that gives us 36.87 degrees, so 37 degrees. So therefore, the submarine is approximately 37 degrees north of Jack's ship with respect to a line pointing straight down. So approximately 37 degrees north of Jack with respect to, so you can do WRT, with respect to a line pointing straight down. So there you go. So guys, I know this was a long video, but there's a lot of success criteria here. What do you need to do in order to be successful? So I would read through this and see how you feel about this stuff at this time. And then try the practice. So I already gave you the answers for number 1. The answers for number 2, this should be 23 degrees, 41 degrees, 30 degrees, and 39 degrees. So try those. I'm going to be looking that they have the right notation to see if you understand the notation, because that's really important with trig. Okay guys, so that's your introduction to trigonometry. That'll be the longest video because I set up so much in one day. But thanks for watching, and I hope you learned a lot.